All right, so let's talk about empirical formulas. First of all, the definition of an empirical formula is the simplest of elements. Okay, so for example, you have C6H12O6. The empirical formula for that, you're just going to simplify it, is CH2O. Okay, so right here is your empirical formula, the most basic ratio of elements. Okay, so let's talk about and let's look at how we figure this out. So the example. So what is the empirical formula of a compound that is 80% carbon and 20% hydrogen? Okay, so step number one is going to be convert percentages grams. All right, and the way we do that is pretty simple. So we have 80%. We're just going to change the percent to a G, and there we go. So we have 80% and 20%. Now we have 80 grams and 20 grams because we're just going to assume that it's a 100-gram sample. Okay, so that's how we do that based on that assumption. Step number two is to convert grams to moles. Okay, so it said that we had 80% was carbon. So now we have 80 grams. We'll do carbon here and hydrogen there. So 80 grams. Look on your periodic table. You have 12.01 grams per 1 mole of carbon. Okay, and that's going to give you 6.66 moles. And then hydrogen, you have 20 grams. 1.01 grams of hydrogen is going to give you 1 mole of hydrogen. And when you divide that out, you end up with 19.8 moles. Okay, so we've converted our grams into moles. Step number three. You're going to divide each number by the smallest mole. Okay, so you're going to divide each one of these by the smaller one. So which one is smaller? That one's smaller. So we're going to divide both of them by 6.66. Okay. When we do that, we're going to drop it down here. We have 1 mole of carbon, or sorry, not 1 mole, we've divided by a mole. So we have 1 carbon, 18.8 divided by 6.66 gives us 2.97, which we can just round to 3. Okay, so we're going to round to the nearest whole number when it's that close. So we have 3 hydrogens. So our answer here, we have 1 carbon from right there, and we have 3 hydrogens from right there. So this is our empirical formula. Okay, let's do a couple more examples. So the question is, what is the empirical formula for a compound that is 40% carbon, 6.6% hydrogen, and 53.3% oxygen? So again, the first step, convert those percents into grams. So we have 40 grams of carbon, hydrogen here, oxygen there, 6.6 grams of hydrogen, and 53.3 grams of oxygen. Okay, that's step number one. Step number two, convert them all into moles. So 12.01 grams per mole for carbon, 1.01 grams per 1 mole of hydrogen, and 16.00 grams per mole for oxygen. So when we do this math, we end up with 3.33, 6.57, and 3.33. Okay, so the next step, all right, we've converted it into moles. Now we're going to divide by the smallest mole. So the smallest one among these three is 3.33. So we're going to divide them all by 3.33. Okay, and we end up with 1, 2. So our empirical formula here, H2O. Okay, because we have 1 C, 2 H's, 1 O. Right, and that's pretty much it. Let's do one more example because there's one thing that I want to show you that could mess you up a little bit. So our last example, we have something that is 56.3% phosphorus and 43.7% oxygen. All right, so the steps are going to be the exact same. So we have 56.3 grams of phosphorus here and our oxygen there. And we have 43.7 grams of oxygen. Step 2, convert them into moles. So using your periodic table, you have 32.07 grams per mole of phosphorus and 16 grams per mole of oxygen. Divide those out and you get 1.76 and 2.73. Okay, now, same steps as before. You're going to divide by the smallest mole. So the smallest one is 1.76. You're going to divide them both by 1.76. Okay, here's where the problem comes. You have, obviously that's 1. Okay, and then this is going to be 1.5. But you can't put a 1.5 as a subscript, and that's not close enough to either 1 or 2 to round it in any direction. So what we're going to do is we're going to multiply them both by 2. So now we have 2 phosphorus and 3 oxygen. Okay, so anything that's, 1.4 to 1.6, okay, you need to go ahead and multiply that by 2, all right, to get an actual whole number for the ratio. And it doesn't have to be 1.4, it could be 2.4, 2.5. All right, anything that's in the 0.5, 0.4 to 0.6 when you're doing this step right here, okay, that's when you need to multiply by 2. And not only that one, but you need to multiply them all by 2. Okay, so the ratios are still the same. And that's it for empirical formulas. It's just the simplest ratio of the elements for a compound.